Just take a look around you for a second. The room you're in, the road right outside your window, even the water that comes out of your tap. None of that just appeared out of nowhere. Today, we're going to pull back the curtain on the invisible architects of our entire world, civil engineers.
I mean, think about your daily commute. That smooth pavement under your car, the bridge you cross over a river without even thinking about it. Yeah, those are not just happy accidents of nature. Or how about this? You turn on a faucet. Instantly, this massive, unseen network of pipes, treatment plants, and pumping stations all kicks into gear just to bring clean, safe water right to you. It's kind of amazing, right?
And right now, no matter where you are, you're almost definitely inside a building, a structure that was specifically designed to be safe, to be functional, and to not fall down. Our entire lives, from home to work to school, they all play out inside these carefully engineered spaces.
So, who are the masterminds behind all of this? This huge web of infrastructure that we all depend on? The people who literally design, build, and maintain modern society? Well, those are the civil engineers.
So, let's get into it. What is civil engineering, really? To figure that out, we're going to take a little trip, all the way from the age of the pyramids to the era of modern pipelines, and really uncover what it means to build for a civilization.
Okay, so here's the textbook definition. At its absolute core, civil engineering is the art and science of shaping the world around us. It's about designing, building, and maintaining, well, everything. From the really big stuff, like dams and airports, to the essential things we never see, like our sewer systems. But why the name civil engineer? It's actually pretty cool. For centuries, pretty much all major engineering was military engineering. Think castles, catapults, fortifications. It wasn't until the 1700s that this guy, John Smeaton, basically said, hey, my work is for the public, for civilians, not for the army. And boom, he coined the term civil engineer to make that distinction clear.
And the history here is just incredibly deep. You can see the roots of this work in the Great Pyramids of Egypt and, of course, in the absolutely legendary roads and aqueducts of the Roman Empire. But things really started getting official with pioneers like Smeaton. And the big moment came in 1828 when the Institution of Civil Engineers got a royal charter formally recognizing it as a true profession essential to society.
Now, civil engineering isn't just one single job. Oh no, it's a huge universe of different specializations, and every single one is a critical piece of the puzzle. So, let's meet a few of the many faces of this incredible field. All right, picture a skyscraper. The structural engineer is the one who designs its steel skeleton so it can laugh at gravity and high winds. Below that, the geotechnical engineer is analyzing the dirt and rock to make sure the ground itself can hold up that massive weight. And then you have the construction engineer. They're like the conductor of an orchestra on the job site, making sure the blueprints actually become a real building.
Then you've got the engineers who manage our societal lifelines. A water resources engineer might be managing an entire river basin. The environmental engineer designs the plant that makes that river water safe to drink. And a transportation engineer, they're basically choreographing the non-stop dance of cars, trains, and planes that keeps our economy moving.
So, how does someone actually become one of these world builders? And what does their toolkit even look like, now that we're in a totally digital age?
Let me tell you, the path to becoming a licensed professional engineer is tough, and for a very good reason. People's lives are on the line. It starts with a demanding 4-year degree. Then you have to pass a huge exam on the fundamentals. Then you need years of real-world, supervised experience, and only then can you sit for the final, comprehensive licensing exam. Every single step is there to make sure these folks are absolutely ready for that responsibility.
And you can forget about old drafting tables and slide rules. The modern engineer's most important tool is the computer. Today, our most complicated structures are built twice. First, as a perfect digital model, and only then do they get built in the real world.
And this digital toolkit is seriously powerful. You've got software like AutoCAD for all the nitty-gritty details of roads and construction sites. Then there's Revit, which can create these intelligent 3D digital twins of entire buildings. And then there are these super-powered programs like STAAD Pro that can simulate a 100-year flood or a massive earthquake on a skyscraper, all to make sure it's safe before a single piece of steel is ever put in place. It's incredible stuff.
So you bring all of this together, the intense training, all the different specializations, this amazing technology, and it all serves one ultimate purpose: to build the world of tomorrow and leave a lasting, positive impact on all of us.
You know, there's this quote from that original 1828 Royal Charter that just captures the whole spirit of the profession perfectly. It's about directing the great sources of power in nature for the use and convenience of man. It's all about harnessing physics, gravity, water, the strength of materials to build a better world for people.
When it comes right down to it, civil engineering is the invisible backbone of our world. Without it, we don't have ports for global trade, we don't have clean water, and we don't have safe buildings to shelter in during a storm. It's the foundation our entire economy and public health are built on, and now it's the field that's building the sustainable, smart cities of the future.
So, as we look ahead and face huge challenges like climate change, rapidly growing cities, and crumbling old infrastructure, the role of the civil engineer has never been more important. The only question is, what's the next great challenge we're going to ask them to solve? Thanks for diving into this with me.